Energy is required to remove the one more electron from the outermost shell. It is known as second ionization energy. The NH bond which is there in the nitrogen along with the hydrogen, it will become very closer to each other, and as a result of this, their bond angles which is also get distorted. When two atomic orbitals are combined, it forms a lesser energy molecular orbital. They are known as bonding molecular orbital. Hello my dear students, a warm welcome you all. Myself is Purnima, lecturer in Department of Chemistry at Vidhyaashram Pre-University College, Temple of Excellence, Mysuru. My dear students, as we have already discussed about the first PUC Chemistry model paper which has been released from the Pre-University Board, we are continuing the remaining part of this model paper. So in the first session, we already discussed about the 1 mark and the 2 mark question. Today, we are going to extend with the 3 mark question. Okay. So let's see how in the part C, the question will come. So again in a part C, there are 10 questions will be there. You need to answer only 5 questions. Each question will carry 3 marks. So it gives rise to the 15 marks. So the first question will be goes like this. Define ionization enthalpy and how does ionization enthalpy vary in a period and down a group in the periodic table. So already in the unit 3, we have discussed that what is ionization energy or ionization potential or ionization enthalpy, right? So it is nothing but a energy required to remove the electron from the outermost shell of the neutral atom. So that is said to be ionization enthalpy. And when we are discussing with this ionization enthalpy, we know that we must know this ionization enthalpy along the period and down the group. As we move along the period from the left to right in the periodic table, this ionization energy will be usually increases along the period and it will be decreases down the group. Do you know why it will be increases along the period? Because as we move from left to right in the periodic table, the atomic number of the each element will be get increased. So that the electrons are being added to the same shell. So it is very easy to remove the electron which is there in the outermost shell. That is why this ionization energy are increases along the period. But as we move down the group, this ionization energy will be decreases. That is mainly because as we move down the group, the number of shell will be going to be increased. As the number of shells are increased, so it is very difficult to remove the electron from the outermost shell, right? So that is why, it will be started decreasing. So because of the atomic size which is increases down the group and it will be decreases along the period, that is why, this ionization energy will be increases along the period and decreases down the group. So here you can understand this by taking up with the magnesium. So we know that magnesium is a neutral atom where it consists of 12 electrons. In the outermost shell, it consists of how many electrons? 2 electrons. So the energy which is required to remove this last electron is known as first ionization energy, and energy is required to remove the one more electron from the outermost shell. It is known as second ionization energy. So it is very important to know this, how it will be increases and it is decreases along the period and down the group. So for your board exam, just state what is ionization enthalpy, just define it, what is ionization enthalpy, then write how does it increases or decreases down the group. Okay. Next we have explain the shape of ammonia molecule by using VS-EPR theory. So first of all, we must understand that they have given the molecule known as ammonia. By using the VS-EPR theory, we need to explain the shape of ammonia, right? So what does VS-EPR theory say? VS-EPR theory, it is nothing but a valence shell electron pair repulsion theory. According to this, we need to explain the structure of ammonia. So we all know that ammonia, in the sense, it consists of nitrogen, right? So it consists of what? Nitrogen. So ammonia has a nitrogen with a 3 hydrogen, as we know that. So nitrogen is a central metal atom which is having the atomic number 7. So what is the atomic number of nitrogen in ammonia? It is 7. And electronic configurations of this ammonia, it is 1s2, 2s2, 2p3. 1s2, 2s2, 2p3. By looking at this electronic configuration, you can clearly see that there are 5 electrons will become unpaired. The 5 electrons will become unpaired. Five electrons are unpaired in the nitrogen, right? So there are 5 valence electrons will be there in the nitrogen. So this all 5 valence electron can easily pair up with a 3 hydrogen atom and forms a 3 bond pairs. But remaining, the 2 electrons will be remain as such in the ammonia and it will become a lone pair. So this is how we need to understand if any molecule which is given. First see that what is the central metal atom, what is the electronic configuration of central metal atom, how many electrons are become unpaired, so how many electrons are there in this molecule. Just try to understand first, then go with the production of the shape of that molecule. Okay. So in ammonia molecule, atomic number of nitrogen is 7 and it has an electronic configuration of 1s2, 2s2 and 2p3. So in the last shell you can see that there are 5 electrons will be there, right? Among this 5 electron, which is also known as valence electron, out of which 3 can easily share with the hydrogen and forms a single bond with the hydrogen, and the 2 electrons are remain as such and it will behave like a lone pairs. Now if you count the number of electrons in the nitrogen atom, there are 4. How come? You can see that there are 3 bond pairs and 1 lone pairs will be there. Hence, the number of electrons in the ammonia is 4. By this, we can clearly say that it is pyramidal in shape. It is in the pyramidal shape. Okay. So, how do we calculate the electron? By counting the number of bond pairs and number of lone pairs. So, number of bond pairs is 3 and 1 lone pairs will be there. So, it is 3 plus 1 which is equal to 4. And 3 it is nothing but a bond pair and 1 which is nothing but a lone pair. Okay. This is a number of electron. Number of electrons in the nitrogen atom. Now, according to the VS-EPR theory, if you are predicting the shape, we must know that ammonia molecules will exhibit a tetrahedral shape because it has a 4 electron, right? And due to the presence of 4 electron, among them 3 are bond pairs and 1 is lone pair. So this lone pair of electrons which is there in the nitrogen, which causes a greater repulsion. Which causes what? Greater repulsion to the bond pairs As a result of this, the NH bond which is there in the nitrogen along with the hydrogen, it will become very closer to each other, and as a result of this, their bond angles which is also get distorted. So by this, we can clearly say that ammonia will have a irregular shape since one of the tetrahedral positions are occupied by the lone pair. The shape of the ammonia will be looks like this. Okay, so it is a pyramidal shape. So how do we write? You can see that central metal atom is a nitrogen surrounded by 3 hydrogen atom, and it has one lone pair of electron. Okay, this is how we need to understand the shape of the given molecule based upon valence shell electron pair repulsion theory. Hope you all understood with the reason, and how to predict the shape also. Hope you all understood. We'll go with the next question. Okay, what are sigma bonds and why sigma bond is stronger than the pi bond? So again, this is a question from the unit 4, chemical bonding and molecular structure. So in this unit, it is very important to know that what is a sigma bond and what is a pi bond which has been formed between the atoms, right? So sigma bonds, as we know that it is formed by axial overlapping, right? Whereas the pi bonds which is obtained by sidewise overlapping. So sigma bonds are formed by axial overlapping or end-to-end overlapping of two half-filled atomic orbitals of opposite spin. So if any two atomic orbitals are there which is having half-filled opposite electron spin, if it is overlapped axially or on the head to head or on the end to end, you can say, such overlappings are known as what? Sigma overlapping. Sigma bonds are formed by head-on the overlapping of atomic orbitals, whereas the pi bonds are formed by the axial overlapping of atomic orbital. In the examination, it's enough to define what is a sigma bond and how does it is formed. But in the same question, you can see that why sigma bonds are stronger than the pi bond they have been asked. So how do you say the sigma bonds are stronger than the pi bond? That is mainly because in the sigma bond, the formation of the sigma bond will always taking place at an axial overlapping, right? So in the axial overlapping, what will happen? The atomic orbitals will have their own direction, right? So it will have its own internuclear axes. So this will not get disturbed when they are overlapped. That is why the sigma bonds are stronger than the pi bond. Whereas in the pi bond, this internuclear axis will get disturbed due to the sideways overlapping. That is why the pi bonds are always weaker when it is compared to the sigma bond. So since the formation of the sigma bond, the orbitals along with the internuclear axis, which results in more effective orbital overlapping as it is compared with the pi bonds, so which is perpendicular to the internuclear axes in the orbital overlapping, which results in sigma bonds to be more stronger than that of the pi bond. So hope you all understood that what is a sigma bond and how to answer it with the sub questions which has been framed within the question. Okay, so first you need to say what is sigma bond and how does that sigma bonds will be formed. Okay, next try to see that if any sub questions are given like why sigma bonds are stronger than the pi bond, you need to give just a justification for that. Okay, so this much is enough to get a 3 marks. Next, write any 3 postulates of molecular orbital theory. So it is also known as MOT. Again, this is a question from the inorganic chemistry, the unit 4, chemical bonding and molecular structure. In this unit, Please understand there will be a 3 question in the 3 mark question. So that is why. So you have a lot of choices this time. You can attend any of this question and you can easily get 70 on 70 on your first PUC chemistry, and they will give almost all the easiest question. So how do you say that? Which are the postulates of molecular orbitals theory? Let's discuss now. Molecular orbital theory are formed by linear combinations of atomic orbitals, and molecular orbitals are the region in the space and where there is a maximum probability of finding the electrons around the nucleus of the molecules are easy. And also when two atomic orbitals are combined, okay, linearly forms one less energy molecules, they are known as bonding molecular orbital. When two atomic orbitals are combined, it forms a lesser energy molecular orbital. They are known as bonding molecular orbital. It can also form higher energy molecular orbital. It is known as anti-bonding molecular orbitals. It is known as what? Anti-bonding molecular orbital. This is a second postulate. And third postulate says that the number of molecular orbitals are formed is equal to the number of atomic orbitals combined. Which means to say that suppose in the hydrogen molecule, we know that hydrogen molecules are formed by two hydrogen atoms, right? Yes. The number of molecular orbitals are formed which is always equal to the number of atomic orbitals which is combining, and the half of these are bonding molecular orbitals and half of this are anti-bonding molecular orbitals. So just give any proper 3 postulates of molecular orbital theory. Okay, this much is enough to give or to write the 3 postulates of MOT. Okay, next we have consider the element sodium, fluorine and iodine. They have given the 3 sub-questions. So what is the first question says? Identify the element that exhibit only the negative oxidation state. Negative oxidation state. And second question says that identify the element that shows positive oxidation state. And third question says that identify the element that exhibit both positive and negative oxidation state. Here you need to answer that, you need to understand that this is a question for the 3 marks, but in that question also there are 3 sub questions will be there. Each of the question will carries 1 mark. Okay. Now if you see that element which is given at the beginning, that sodium, fluorine and iodine, in that element we need to decide that which element which is having negative oxidation state, which element which is having both negative and positive oxidation state, which element which is having positive oxidation state. So by looking at that element, you can clearly say that the element which gives a negative oxidation state is nothing but a fluorine. The elements which gives a positive oxidation state is nothing but a sodium. The element that can shows both negative and a positive oxidation state is nothing but a iodine. So if you write this much, you will get 1 mark. Okay, and one of the easiest question it is. Next, mention the 3 uses of dihydrogen. So again, it is a question from the inorganic chemistry. So you need to understand that here any 3 uses if you write, this much is enough. Okay, so here we need to write the uses of what? Dihydrogen. where you will use the dihydrogen. We all know that it will be used in synthesis of ammonia and in the nitric acid and also in the nitrogenous fertilizers. And not only in the ammonia synthesis or in the nitric acid or in the nitrogenous fertilizers, it is also used in preparation of vanaspati or in the manufacturing of vanaspati. Then this dihydrogen can also be used in the manufacturing of methanol and metal hydrate and also in HCl, etc. It is also used as what? Reducing agent and used in fuel cells for generating electricity, and it is also used as gaseous fuel for generating the electricity in the fuel cell. And oxyhydrogen torches also be used for cutting, welding purposes, and also it is used as a rocket fuel. Any three uses is enough to get a 3 marks. Any three uses you can write. I have listed out the 4 one. Any three you can write. Next, how is sodium hydroxide prepared commercially by Kastner-Kellner cell? So in the Kastner-Kellner cell explaining, I have shown you that how does that Kastner-Kellner cell will be looks like. By using that cell, how do they prepare the sodium hydroxide also I have explained. Just recall it once again. So we know that sodium hydroxide, it is nothing but a NaOH, right? So NaOH, you need to say that how this manufacturing process will be happens. Sodium hydroxide is manufactured by taking the brine solution and they'll do the electrolysis. By electrolysis of brine solution using copper as a cathode, carbon as a anode in the Kastner-Kellner processes, we can prepare the sodium hydroxide. Okay, so what do they use? They'll take the mercury as a cathode, carbon as a anode, and they'll take the brine solution. So what is the brine here? So brine, it is nothing but a concentrated solution of sodium chloride. Concentrated solution of sodium chloride, which is also known as what? Brine solution. They'll take the brine solution and they'll put it in the Kastner-Kellner cell where it is having mercury as a cathode, carbon as an anode, and they'll switch on the electrical current. When you are doing the electrolysis, we know that the solution which consists of sodium chloride, it will be split and give rise to the sodium ion and the chloride ion. This chloride ion, we know that it always accept the 2 electrons and it get reduced. Whereas the sodium can loses 1 electron and become oxidized. Later, they will send the sodium to the another chamber known as decomposer where it is combines, they'll send the sodium to the another chamber where it combines with the mercury and forms a sodium amalgam. And forms what? Sodium amalgam. Later, this sodium amalgam, it will be sent to the separate chamber known as decomposer where sodium amalgam will be washed with water and to form a sodium hydroxide. To form what? Sodium hydroxide, and again the mercury will be leaves behind and hydrogen gas will be liberated out. Okay. Again this sodium hydroxide will be collected at a one chamber and this mercury will be again, it will go back to the reaction, it will be recycled back and it again reacts with the sodium metal and forms a sodium amalgam. So this is one of the important method where we are going to prepare the sodium hydroxide by using Kastner-Kellner electrolytic cell. Okay. Hope you all understood with this method. Next, give the chemical formula of plaster of Paris and limestone. So we all familiar with the plaster of Paris, is it right? For the broken hands and in the construction, especially for making the statues and for making the toys and all, we use a plaster of Paris, and it is nothing but a copper sulfate hemihydrate. So how do we write? CaSO4 half water molecule. For the limestone, we know that it is nothing but a calcium carbonate. Just by writing the formula, it's enough to get a 3 marks. Next, write any 3 anomalous properties of boron. So for this question, you need to write the 3 anomalous behavior of or 3 anomalous properties of boron. We know that boron, it is a trivalent halide, hence it is a covalent in nature and it can be easily hydrolyzed in a water, and boron can form tetrahedral species, whereas the other group of this p block elements, they forms tetrahedral as well as with the octahedral species. And if you see that boron, do you know what is the electronic configuration of the boron? It consists of atomic number 5 of boron, and it has 1s2, 2s2, 2p1. 1s2, 2s2, 2p1. You can see that there is an absence of d orbitals will be there. So due to the absence of d orbital, the maximum covalency of boron is 4, whereas the other group of this species, they shows beyond 4. Their covalency become more than 4 when you are considering the same group of elements. And boron oxides are acidic in nature, whereas amphoteric oxides are basic in nature. So any 3 anomalous property if you state for the boron, it's enough to get a 3 marks. Next we have write any 3 differences between graphite and the diamond. So it is very easy to write the differences between graphite and diamond. Any 3 differences you must write. So we all know that diamond, which is very hard and it is a white and a crystalline solid. Coming into the graphite, it is a soft grey and crystalline solid. And we know that this diamond will be having tetrahedral structure, whereas graphite will be having hexagonal planar structure. Hexagonal planar structure. And also if you consider the diamond, each carbon atom attached to 4 other carbon atoms, whereas in the graphite, each carbon atoms are attached to 3 other carbon atoms. So here each carbon atoms in the diamond can attach with the 4 other carbon atom, whereas in the graphite, each carbon atoms will be get attached with the other 3 other carbon atom. Coming into the last differences, all the electrons are bonded. So the diamond is a bad conductor of electricity, whereas the carbon that is in the graphite, which contains one of the free electron, hence it is a good conductor of electricity. This is how, if you write the 3 differences between the graphite and with the diamond, you can easily get the 3 marks. Any 3 proper differences you must write. So hope you all understood with the 3 mark question how to attain and how much to write in the 3 marks, that is in the part C. In the next session, I am going to discuss only with the part D. Till that, take care, be safe. Thank you.